All right, welcome everyone. We're going to go ahead and get started here. Thanks for joining us today. This webinar is going to be about enabling safe and reliable generative AI for financial services with focus on RAG techniques and challenges. My name is Skip Everling. I'm the head of developer relations here at Kolena, and we're also going to have Gordon Hart joining us. He's heading up our product organization and is one of the co-founders of Kolena. So without further ado, here's the agenda for today's webinar. First off, I'm going to take a brief overview of RAG systems. In case you're not familiar, it won't be a deep dive, but it'll give you a good sense for the technical concepts so that you can understand the techniques that we're going to explain to you later. And in particular, we're going to be looking at some use cases for finance and how RAGs, what they enable beyond the way that AI is already being used in finance. What RAGs add to the table, add value here. So, and we'll go through several of these key use cases. It won't be exhaustive. There's a big list of potential use cases for a system like this, but we'll go through some of the top examples. Go through some benefits, risks, mitigating failure modes. Then Gordon will take over. We're going to look at benchmarks specifically, techniques for improving your RAG systems, in general, like how you would use a benchmark, what kinds of things you would use in terms of your evaluation process, and a little bit more about the philosophy behind that. We'll wrap up with talking about what does it mean to set a gold quality standard. So what does it mean to have a complete standard so that you can reliably move forward with what you want to deploy in terms of these RAG systems use cases. And then we'll spend just a few minutes thinking about what does the future hold. So obviously RAGs are changing very quickly. The industry is changing very quickly. The way things are right now is not going to be the way things are in a year. What does that mean in terms of practical guidance for you when you're trying to implement a system like this? All right, hope you're excited for that. Just a quick word before I get started with the main talk about Kolena. Kolena, we're the AI quality company. We hosted this conference, our first conference, about a month ago. Huge success. It was great. It's called AIQCon. The talks are starting to be posted now on YouTube. You can just search for AIQCon on YouTube. It's also on Kolena's YouTube channel as well. Yeah, it was great. We had a lot of very cool speakers, very cool venue there in this Hibernia Bank in San Francisco. And yeah, all this to say that Kolena is really focused on this idea of AI quality. What are the ways to achieve that? What are the best practices? What are the techniques? What is the latest knowledge? Things like that. Well, all right. So what is RAG? Let's get started just with a conceptual overview of what RAG means. So RAG, of course, stands for Retrieval Augmented Generation. It's effectively a way of enhancing the output of generative language models. Generative language models you're all familiar with, things like ChatGPT, LLMs. The system, it starts with a basic LLM would just start with a query. So you would send a query to a foundation model like GPT. You would get back a response. There was no retrieval of additional information happening there. What happens with a RAG system is that it incorporates this retriever component, so the R in RAG, where the system will query this knowledge store to retrieve relevant information to the query, and it will incorporate that into an answer so that you end up with a more context-rich and accurate response. So this is basically a full but simplified diagram of what a RAG system looks like. Got the initial query. That query is sent to a retriever, which has this corpus, this knowledge store, which is then filtered for relevant information based on the query. That all goes to the generator, which is the thing that's creating the output, the response. And then you get the answer back to the end user. So the key idea is really this: you're adding this retriever component, you're adding this information retrieval component, and that makes a big difference in terms of the quality of the answer. Retrievers and RAGs, so information can be retrieved from virtually any retrieval system. So it could be a single passage, it could be a vector database, very common at this point. Even the entire internet, that's what search engines do. This is an information retrieval problem, basically. Going back to the vector database thing, usually before storing information into a database, the data is vectorized and indexed and that makes it so that that information can be retrieved quickly by the retriever. When a new query comes in, it searches for similarity between the vector of the query and the vector of the information in the vector database, and then pulls that out very quickly and presents that as relevant information. And yeah, again, this is information retrieval, which is a field that is as old as computer science at this point. It's widely studied. There's a lot of literature, and there's lots of ways of retrieving information. RAG is just the latest iteration of that applied to LLMs and applied to this generative AI side of things. You're combining this information retrieval with the generation side of things to create a new system, this RAG system, a very powerful system. But the good news there is that there's a lot of science and research that's already been done on information retrieval that we can be applying those learnings to as we develop RAG systems. So just to expand a little bit on the RAG architecture diagram here, because it might help understanding later on when we're getting into some more of the specifics of how to look at RAG performance and how to optimize and techniques. This is the same thing, but the retriever and the generator have been expanded here. So typically the query will go into this vector database. Like I mentioned, you have this vectorized version of the information. You have vectorized versions of the documents. So coming from the document corpus, set of PDFs, for example, we're going to take a look at FinanceBench later, which is effectively a big corpus of PDF documents. Those documents are broken down into chunks, which then get vectorized. And using basically a similarity search in those vectors between the query and those chunks, the relevant chunks are surfaced. So the retriever's job is to pull out those chunks and then rank them effectively to say how relevant they are. Those relevant chunks are what go to the generator along with the query. The generator is taking the prompt, so the instructions. It's using whatever information it has from these relevant chunks in context, so it can reference those directly and give a better answer, similar to if you had told ChatGPT something and then asked it about it. It's got it readily available, and that improves the quality of the answer, and that moves forward to generating the answer. So again, this is just a way of saying how do you get from these set of documents, how does that actually contribute to generating the answer? It's by bringing up relevant chunks and making them available to the generator. Cool. So coming back to finance specifically now, we've seen what RAGs are. It's adding information retrieval to the generative side. What are some of the use cases that are common here? And I guess I'll start off here with the why of this. Like, what is it that RAG is really doing? What is it really adding? The key point is that the basic approaches, they still have major limitations, and RAG addresses these limitations by combining the power of information retrieval and generative AI. So I have this table here. On the traditional AI side, there's often outdated information or limited retrieval scope. So whatever information is not necessarily up to date because it's unable to reference the most up-to-date documents. A RAG system is designed to have this corpus that is being continuously maintained and in real time, and that can be retrieved just as quickly. And so you've got that stuff readily available. Limited domain-specific knowledge. So if you're just using a foundation model, it's whenever it was trained. It may be months ago. It's not likely to be up to date simply because it is a point in time where that knowledge was crystallized. What RAG systems enable here is you can utilize a corpus that is adapting all the time, and you can use financial docs, big financial databases that otherwise wouldn't be part of the training of a foundation model. So you're adding this domain knowledge, which can have a powerful effect and is actually super important for something like finance, where having that domain knowledge makes a big difference. The other problem with traditional AI approaches is black box problems, basically, where it's hard to trace and account for decisions. Why did the generative AI give the response that it gave? The value with RAG systems is that because you know which documents you're drawing from, you can actually cite those sources and you get transparency. So you can see exactly where the generator got the information that it's conveying. And that really helps you to debug and test, diagnose, understand, and explain to regulators, for example, the reasons for why your Gen AI did what it did. And then, of course, the very famous hallucination problem. Lately, confabulation is the latest term for this. But when LLMs lack references, they don't necessarily acknowledge that. They might just make something up and do it confidently. And that can be a very big problem because it's not clear when that's happening. What RAG systems really do is because the relevant information is in context, the generator is much more likely to prioritize these data-backed responses, and therefore it vastly will reduce hallucinations because the LLM doesn't need to fill in with, whatever information it thinks might fit there. It actually has that information that it can draw on directly. So there are a lot of big benefits for using a RAG system versus traditional approaches. Going to this just a little more, here are basically the key benefits you're getting. You're getting timely insights, keeping pace with changing conditions. You're going to get the ability to do comprehensive analysis. So you're drawing from these vast financial data sets, tons of information available that isn't being used necessarily without the ability to do information retrieval in this way. Transparent decision making, just like I mentioned, this is particularly important for regulatory compliance, but also for client trust. Just making sure that your users understand that what they're getting is correct. That's very important if you actually want to have adoption for some of these products. And the last but not least, credible and accurate responses. So there are a lot of high stakes contexts in the financial domain, and you want to make sure that you have credible and accurate responses to back up your brand and your reputation and your service. So I'm going to go through just a few key use cases before we dig into the particulars of techniques for improving RAGs. I've listed a few here. These are some of the cases that have emerged for the more tech-savvy financial institutions, and increasing adoption every day, but these are the ones that have jumped out. So investment decision-making, obviously, when you're trying to decide where to invest, whether as a company or an individual, you have a lot of information that you need to go through, a lot of different kinds of documents. RAG is especially helpful for that. Doing things like know your customer background check processes, just making that very efficient by retrieving the most relevant information and being able to make a decision quickly. Going back to investing, so the ESG and sustainability research, there's this whole other corpus of information that can be useful there when you're trying to evaluate this new domain in relation to another domain, and you can have documents, you can have a data store that represents the relevant information and draw from that. Automated customer support is an obvious one. If you've got a chatbot and you want to provide automated customer support, you want to make sure that that's reliable, that it's doing the proper interactions with your customers. It's not giving them financial advice when it shouldn't. It's not telling them the wrong information about their accounts, things like that. Personalized investment advice, very related to that. And then improving risk assessment and fraud detection. So being able to catch when fraudulent type activities are happening because you have a more real-time access to information and that document store that's up to date and more comprehensive. And this list is growing, but this is just kind of some of the big patterns that are right off the top. So I'm going to go through just 3 of these in a little bit more detail, and you'll start to see some patterns here. So if you're thinking about this investment decision-making, private company pre-screening for investment decision-making here, example would be you're a private equity firm, you're using RAG to analyze potential acquisition targets. Benefits, you get faster due diligence, you get more comprehensive analysis. It's probably a lot easier to get a complete picture right off the top if you have a good document store. But there are risks. I'm calling this RAG risk, but basically this is the risk if you don't have a well-implemented RAG system. So if you either have a system that's underperforming, or if you don't have the system at all, or you're using something that's not quite right. If you end up with incomplete data retrieval, you're going to miss critical information. You might make a bad decision. That's going to be potentially extremely costly and ruin the whole thing. Biased information retrieval is another thing. So if the retriever is not perfectly neutral, for example, you need to be aware of that. Outdated information, of course, is a huge one. You want to make sure that what's being retrieved is the most recent and relevant version of what is being asked. or what you're curious about. The tip there is just ensuring that the RAG system has access to a wide range of this up-to-date, reliable financial information that's obviously relevant to whatever, investment decisions that you're looking at, and regularly auditing and updating those sources to maintain data freshness and relevance. Relatedly, going to the next use case, so thinking about rapid know your customer, that's KYC here, background checks for compliance. For example, you're a bank using RAG to streamline customer onboarding. You need to do background checks before they can open an account with you. Benefits, you get faster processing and more thorough checks. Obviously, huge potential gain there. The risks, very similar here. Failure to retrieve all the relevant documents, potentially missing red flags. That means you can't really trust the system, which means you can't really use it at all. So you have to make sure that you're mitigating that. Inconsistent retrieval, very related. So if you aren't treating your customers fairly, then that's going to be a compliance or regulatory issue, or an ethical issue even. And that's something that you have to make sure that your retriever is handling in a balanced way. Same thing, if you're retrieving irrelevant or misleading information, then that's going to kind of ruin the system and make it not even worth it. One tip that I've seen in this particular domain is just establishing these clear retrieval boundaries. So define explicit parameters for what constitutes relevant information. And you can implement this hierarchical type retrieval system that prioritizes what's relevant here for this client compliance related information. Last use case, I'll do this little deep dive on, but the whole point is patterns are merging here. Personalized investment advice for consumers. So if, say, you've got a robo-advisor using RAG to provide tailored investment recommendations, obviously big benefits. You provide more personalized advice. People will trust the system to give them advice, and then that has a very positive feedback loop. Can be a really great thing. The risk, again, is that it's not impressive. So if you're retrieving generic rather than personalized information, your retriever is, or if you're just using like a foundation model right now, that would be essentially not personalized information, and it's only so useful. And it's not really going to be suitable for a product. You need to have the ability to retrieve this extra document information. Same thing, failure to consider all the relevant factors due to incomplete data retrieval or inconsistent retrieval of data. So, for example, inconsistent retrieval of market data, resulting in conflicting advice. You want to make sure that your RAG systems are consistent. So the patterns, you're probably noticing some patterns emerging here in terms of RAG. And you start to ask questions for yourself. There are basically two sides of quality for a RAG system. There's the retrieval side and the generation side. Some questions that you might ask yourself when you're thinking about evaluating these things: am I retrieving the correct context? Am I getting the documents? Am I pulling out the information, the relevant chunks that are most relevant to the type of problem that I'm working on? Within that retrieved information, am I correctly ranking those? So am I using what's most relevant and not what's less relevant? Because there are certainly things that take precedence, things such as recency or completeness with regards to the document information. And of course, are those contexts going to help you reach the correct answer? These are all things on the retrieval system side, which can be measured and evaluated. And on the generation side, is my answer factual? Am I giving something that's factually correct? That's obviously going to be hugely important if you intend to have it giving investment advice, for example, or speaking to a customer directly. Is the answer using the retrieved context? This is a big one on generation side, because you can have the underlying generative AI model generate an answer, and it might even be correct, but is it using the retrieved context? Is it actually making use of the retrieval side of the system? Because if it's not, then it's not really using the value of the system here. And then another question like, is unexpected behavior correctly flagged? So are you keeping track of your failure modes? And if not, taking steps to address that. These are just some examples of the types of questions that should pop up when you're thinking about your RAG system quality. That's really on this retrieval thinking about retrieval separately from generation, and then the whole system together is a whole set of these questions which you're using metrics to evaluate. We'll get into a little bit of that in a bit. All right, so to kick this off, I'd love to introduce Gordon. Gordon is our CPO, co-founder of Kolena here. He was a software engineer and product manager leading real-world AI initiatives since 2016. This is him and Tokyo Narita demonstrating his threat detection system. He's built CVML systems for defense and security applications at Palantir and at Synapse. And he spent the past few years thinking very deeply about testing AI ML quality across industries, data modalities, and task types. Very happy to have you here, Gordon. Welcome.
Awesome. Thank you for that intro, Skip, and for all of that information about how you might use retrieval augmented generation in the finance domain. I'm going to talk specifically here. Let's share this. So I'm going to talk specifically about benchmarking RAG systems and look at a particular use case that's based off of a benchmark data set for mostly information retrieval and financial question answering from SEC Form 10K documents called FinanceBench. Benchmarks for AI testing are standardized data sets and evaluation frameworks that you use to get a signal on how your model performs. This is particularly important for assessing changes that you're making to a system. If you're updating the way that you're indexing your documents into your knowledge store, if you're changing the underlying model, if you're doing prompt engineering, all of those will have maybe subtle or not so subtle impacts on model performance. And having some sort of benchmark that's specific to the task that you're performing is critical to understand, when you're actually improving the system and when you might be inadvertently diminishing its performance. If you've been following along in the space, you've probably heard words like MMLU, GSM-8K, human eval, GPQA. These sort of benchmarks that are commonly cited for large language models as they're released by their model developers are benchmarks that are really suited for the research team, for the team that's doing the development of this general purpose model. But the needs of the research team and the needs of the actual team that's applying these models to a real world use cases, building products around it, those needs differ pretty significantly. And I think there's a conflation often with benchmarks that are for applications in production versus these benchmarks that are for more general performance in a research setting. So I've highlighted some of the ways in which benchmarking differs when you're looking at the actual production application development. In research, in the research context, often you're looking at, you want benchmark data sets that are very, very large. You want them to be extremely statistically significant. If you have the higher number than the previous state-of-the-art model, you want to be able to claim incontrovertibly that you have the best model and you're the new state-of-the-art. In the production context, the size is actually kind of it gets in the way. It makes it slower to run the benchmark. It makes it more expensive. As a result, your team starts benchmarking less. You think about this as something that you're only running maybe once a month or manually, when in reality, benchmarking should be a process that's performed every time you make any change to that model and you push that to production. The scope of research benchmarks should be large and general. For these general purpose large language models, you will want to assess performance across a huge variety of different tasks. For production, you want to scope your benchmark to the exact things that your actual app will be doing. So you want to cut away all of the noise and look at those specific examples that model real world use cases. For the research context, you want a static benchmark such that if somebody tested it 2 years ago and you're testing it now, you can directly compare apples to apples and say, here's how we performed over historical research. But in production, that matters a lot less than ensuring that as the way that your users use your app, as the functionality that you add to your app evolves, your benchmark needs to evolve with it. And you should always be focusing on adding new examples, growing your benchmark data set with real world use cases that you've found that your system maybe underperforms in by looking at your users. So origin laboratory versus real world. And then the last piece that really differs here is in the research context, the measurement that you're primarily looking at is going to be accuracy or some metric that assesses, overall model quality, model performance. When in the real world, accuracy is one of the axes that matters a lot. Cost is an extremely important real world decision driver, as well as latency, because latency, how long the model will take to answer a question, is often going to impact whether or not it's actually usable within a certain product form factor. So with this framing of benchmarks for AI testing, let's look more closely at this FinanceBench data set, where we have a corpus of mostly SEC 10K forms, which will be your yearly filing that's going over your company's finances and all of the different factors at play there. There are many questions in this data set, over 10,000 questions, but in practice, the subset that's evaluated is around 150 examples. And these are diverse scenarios with clear-cut, straightforward questions that you can pretty easily measure the correctness of using an automated LLM judge to assess whether or not the ground truth answer that's provided as part of the benchmark dataset is the same as the answer that your model or your RAG system has produced. So one example here, a user might have this question: what is the year-end fiscal year 2019 total amount of inventories for Best Buy? Answering USD millions. And you see some example responses given from OpenAI models or Llama models, and the correct response is going to be something along this lines, a natural language response that you then go and measure the correctness of. So clicking over to FinanceBench here, we have this loaded in on the Kolena platform, and you can see we've got the 150 data points where we can look at one of these data points, this one, for example, and we have the associated filing. Let's go to this one. We have the associated PDF document. So here we have this Form 10K from the Boeing company in the year 2022. We have a category that's associated with this. So this is a complex calculation problem. And the question that's associated here is, how does Boeing's effective tax rate in fiscal year 2022 compare to fiscal year 2021? The correct answer is given as a part of this benchmark data set, and a justification for the answer is also given for reference for developers, as well as the source page number. So if you're training, if you're setting up some sort of RAG system and you're testing a model against this benchmark data set, you would want to take in this question, retrieve the correct document, so identify this document from your larger knowledge base, retrieve the correct information from this document. So this says page number 55 is what we want to look at. So let's go and look at page number 55 here. And we see that this has a nice table of financial information where we want to retrieve from this the effective tax rate, which is a income tax expense benefit, and then the loss before income taxes. And you want to retrieve these pieces of information, and then your LLM should be able to produce the right answer given the formula that it hopefully understands for effective tax rate. So this is the setup of the FinanceBench data set. If we go over here to this quality standards tab, we can see how we're evaluating performance on this data set. So we're going to look at performance across all of these examples, as well as performance for the different types of questions that are present in the FinanceBench. We have 56 retrieval type questions where you're asking simply for a piece of information to be retrieved from a specific document, one of these Form 10Ks or 10Qs inside this corpus. We have 23 comparison style questions where you'll be looking to compare across companies or across different years for a single company. We have some simple calculations here, 9 simple calculations, 43 complex calculations like that one that we were just looking at, 10 calculations that also require some sort of value judgment on the output of that calculation, 2 where you need to explain some of the factors behind a certain claim, and then 7 that are categorized as miscellaneous other advanced questions. And we're looking at these metrics here where we care about the correct rate, which you can think about as the accuracy, what proportion of overall questions did this model get correct? We're looking at the rate at which the correct document is retrieved from the overall corpus of all of these 10Ks and 10Qs. We're looking at the page retrieval rate, where not only did you get the correct document, these are 150 plus page documents maybe, but did you get the correct page from that document? And this will often be a more impactful, more useful measurement than doc retrieval rate. And we're also looking at this mean query time. How long did it take the system to search the knowledge base, retrieve the correct information, provide the correct answer, and put that in front of the user? So this is one of those real world factors that's highly important when you're benchmarking for a real product. So looking at our baseline where we have the retrieval system and the generation system that Skip showed earlier, we're looking at a baseline where we're using the state-of-the-art frontier model, GPT-4o, and we see that performance on these questions is quite poor. We have an overall 40% correct answer rate with less than 60% correct document retrieval rate and around a 22% correct page retrieval rate with a mean query time of about 3 seconds. So what this says to me is that the default setup, if you're going to use something like, let's say the AWS Bedrock automatic setup for a RAG system based on a bunch of documents, the naive simple setup will yield very, very poor results. And I would really caution against, across all of these different categories, retrieval type questions, complex calculations, I would really caution against using this system in production, given the quite poor rate at which it answers questions correctly. So we're going to look first at one technique that we can use to improve performance for this type of question answering called query metadata extraction. Query metadata extraction is a way for us to improve the retrieval coming of chunks or documents coming out of this knowledge base. As Skip said earlier, typically retrieval for RAG systems in the Gen AI context is based on vector similarity search. You will take the user's query, you will create an embedding that represents hopefully the semantic content of that query, and you'll look for things that are semantically similar inside the knowledge base. But if you've played around with this in practice, you'll notice that this falls quite short and that this doesn't really well model the type of retrieval or search that you'll need to actually get the right pieces of information. So we're looking at this query metadata extraction piece, where in addition to doing regular vector similarity search, we're also running a processing step on this query using a large language model with a special prompt that's instructing it to do this metadata extraction, where we are extracting certain relevant keywords and applying those as rule-based filters for the retrieval step so that we're at least narrowing down the scope of documents that we're using regular vector semantic similarity search for. So this means that during the document indexing process, we're going to extract document level metadata and attach that to each of the chunks that we're indexing into our knowledge base. All major vector databases support this kind of metadata-based tagging and query filtering. Some examples here might be for these SEC documents. Let's extract the company and the year that it corresponds to. And then during this question answering phase, you have this additional processing path where your query gets fed into a metadata extractor, which is, again, it can be the same LLM that you're using for summarization, just with a different prompt. And the output there is our specific metadata terms, key value pairs that you're using to filter down this retrieval step. So an example here, among operations, investing, and financing activities, which brought in the most or lost the least cash flow for Best Buy in fiscal year 2023. This is an example user query, and the metadata extractor will produce metadata extractions where it says the company here is Best Buy and the year is 2023. So when we apply these to the retrieval process, we're now not looking for things across our entire corpus. We now know to look specifically within the Best Buy and 2023 document. So let's go click this link to go over and see this in Kolena. So this is a specific example here where we're again looking at this among operations, investing, and financing services. And we're looking at this specific data point. We have this form 10K on the left, and we have results from two models here viewed on the right. The first model that we're looking at, this baseline model, is the one whose performance numbers we were looking at earlier that only got 40% of questions correct. This baseline model you see is able to retrieve 4 pieces of context here. But a lot of this is not the correct. So this is from Best Buy 2023. That might be good. This one that it retrieved is from Best Buy 2022. That's irrelevant. And you can see that this, collapse these guys. You can see that the generated answer that came from this model that had these non-filtered, these naively retrieved, semantically retrieved context chunks, the model that says the context provided doesn't give a detailed breakdown of cash flows from all of these different sources. Basically, I can't answer your question, sorry. So this is an example where the naive approach does not yield the correct retrieval and your model is not able to generate the correct response. But with the metadata retrieval that identifies we want to just search in Best Buy documents from 2023, we were able to retrieve the correct context. And we see here on this model on the right, we have a model that is using this query metadata extraction as a part of its retrieval process. And the generated answer is here in fiscal year 2023, operating activities generated 1.8 billion in cash flow. And this is indeed the correct answer. So this query metadata extraction was able to improve the performance of this model quite significantly without changing anything downstream of the retrieval task, just changing the documents that are retrieved from the knowledge store. So looking at these results, then comparing this QME-based model with the baseline model here, we can see that we've improved the document retrieval rate. It went from 58% with the baseline, 3 out of every 5 maybe, to about 75%. So we're retrieving from the correct document a more significant amount of the time. Still not perfect, still actually leaving quite a bit to be desired there, but it's a big improvement, about 15 percentage points. And the correct page retrieval rate went from 1 out of every 5, 22%, to 2 out of every 5, 40%, which this is a huge improvement. And it improves the correctness rate from 40% to 44%, but clearly we're not production ready yet. Clearly this one technique, while greatly improving retrieval, didn't make retrieval near perfect or good enough for us to use in a real world context. And the impact that these marginally better retrievals had on performance was about 4 percentage points, which is good. We want that sort of improvement, but it's not enough to really change whether or not the system can or cannot be used in a real context. We can also see here that the extra processing steps here to extract this metadata added a little bit more to the overall query processing time. It didn't quite double it on average, but it did add 2 or 3 seconds of additional processing to the point where your user will now, on average, for this data set, be waiting about 5 seconds to retrieve a response. So we're getting into the red zone in terms of latency as well. So we're going to look at another technique that will further improve our performance here, where this is called query decomposition. And we're going to use a strategy called hierarchical task planning for this query decomposition. Broadly, this is breaking down the task, the query that the user provides, into different subtasks that are each themselves much more straightforward and achievable, that where the answers to those subtasks feed directly into the overall answer to the question. And this will be clear when we look into a specific example here. So in terms of the flow of information through your RAG system, your query now first goes into a hierarchical task planner. This hierarchical task planner is going to map out the individual pieces of a complete answer. And then you're going to use each of those different sub-pieces to retrieve specific pieces of context such that your retrievals from your knowledge base, and we'll use the same semantic as well as metadata-based retrieval that we talked about on the last slide. Your retrieval will now be for each of these subtasks. So you'll have a little bit more targeted retrieval from your knowledge store. So the example of a hierarchical task plan is something like this. This is a nested structure where, let's say, the overall task here, you'll start with an overall task and a model, this hierarchical task planner, which is another LLM. You can use GPT-4o or something else with a special prompt that's instructing it to produce this sort of hierarchical task plan. it's breaking down the overall task into these sub-plans, and you can nest those arbitrarily. So an example here, are there any product categories or service categories that represent more than 20% of Boeing's revenue for fiscal year 2022? This is a relatively challenging question. It's going to have different pieces of information that you want to look for. And the task plan that you'd look at might be something like this. The task plan that the model would produce, this is direct model output that we're sharing here. So here's your question. Are there any product categories or service categories? And the first part of the task plan is identify Boeing's total revenue for fiscal year 2022. You need this because you're going to use this as a part of the calculation for the overall share of Boeing's revenue. The second part of your plan is identifying the revenue from each of these different product service categories in this fiscal year. And this task itself is broken down into two subtasks where you need to figure out what the major product and service categories are for this company in this year. And then for each of those, you need to find the relevant numbers. So we now have 4 subtasks here that all feed pretty directly into this overall question that the user is asking. And each of these itself is a relatively straightforward retrieval and summarization task. So, each of these is quite well scoped and has a lot of the correct keywords to find the right documents inside your knowledge base. So let's go click over to this one as well. Let's go right here. So we're clicking into this example here, where again, we have our Form 10K on the left. We're looking at this question: are there any product categories or service categories that represent more than 20% of Boeing's revenue for fiscal year 2022? And now on this left model, we have the previous one that we were looking at with just this query metadata extraction technique applied. And on the right, we're seeing a model that has this hierarchical task planning or query decomposition strategy applied, in addition to this query metadata extraction that we talked about earlier. So in this case, when we're just looking at this query metadata extraction, the generated answer is based on the information provided in the context. No specific product or service category individually representing more than 20% is explicitly mentioned. This is, again, basically the model saying, you didn't retrieve the right information. I'm sorry, I can't give you a correct answer. So this is an example of a failure case where without this more special degree of hierarchical task planning, you're not able to retrieve the correct information and therefore not able to answer the question correctly. When we do this hierarchical task planning, again, looking at these 4 different subtasks and performing retrieval from our knowledge base specific to each of these subtasks, we can get the correct documents into context, which allows the model to then go through the relatively straightforward calculations because each of the constituent pieces is directly there inside its context. And so it's able to say that, yes, there are 2 areas here. One is commercial airplanes, which is 38.8%, and one is defense, space, and security, which is 34.8% of the overall. And this is an example where, because we have all this information in context, we're now able to correctly answer this question. So one more time, coming back here into this quality standards comparison view, we're going to look at this same query metadata extraction model on the left, and now we're looking at this query decomposition plus metadata extraction model on the right. And we see that this breakdown, this hierarchical task planning for retrieval has improved our retrieval really significantly, because now we have very specific things to look for. We're generally able to retrieve the correct document. We have about a 95% document retrieval rate, which is pretty good. It's getting to the point where you could consider using this in production. And we have maybe 2/3 of the time, we're getting the correct page, the exact page that the benchmark wants us to get from that document. And this is up from about 40% of the time. This marked improvement in retrieval yields a huge improvement in the correctness. So we've gone from answering 44% of these questions correctly to now answering 72% of these questions correctly. And you can see that for some of these different categories, we're getting to the point where we can consider using this in production for certain use cases here. So this calculating the change, we see we have 100% performance. We've got 100% of these correct. So that means that simple calculations, changing in values, is something that this system can now reasonably do, and you can reasonably expect the correct answer. For some of these other tasks, you see retrieval of a specific piece of information. That's still falling a little bit short. It's around 76%. And then these more complicated things, explain some of the factors, use your judgment. These are at 50%, which is a big improvement over 20% or 0% from the previous model. But those are still not quite good enough for us to consider these as real use cases that we would expect to succeed for our users in production. One of the other things to note here is that this hierarchical task planning is yet another processing step that's along that pipeline. And this increases the mean query time from 5.7 seconds up to about 9.5 seconds. And so we're now at the point where this is kind of right on the edge of an interactive program. If your mean query time is 10 seconds before you get a full response, there are techniques that you can do to make your user be okay waiting longer. But 10 seconds is roughly the threshold where users stop engaging with an application if they're waiting that long. They think that it's broken if it hasn't given them a response yet for 10 seconds. So we've walked through here a couple of different ways that we can improve our performance on this FinanceBench dataset and what benchmarking and model performance analysis will look like in production. So I'm going to pass it back to you, Skip, to take us to the quality standards for GenAI systems.
Thanks, Gordon. It's a nice look at the Kolena interface there. It makes it really easy to do these analysis and comparisons. And that was FinanceBench, but it could theoretically be any benchmark, right?
Yeah.
Right. Cool. All right, let me share my screen again. So what I want to talk about now is just to kind of put a cap on the guidance here is developing these quality standards for Gen AI systems. The last screen that we were looking at there in the Kolena interface was the quality standard screen, just to give you a sense of what we're driving towards here. But to give this kind of a simplified example, you can think of a quality standard as a set of criteria focused on the risks, capabilities, testing methodologies, and tolerances. So what we were looking at in the Kolena interface was kind of a more technical oriented type quality standard, but you can think of the quality standard as going beyond that and thinking about risks and in addition to those capabilities, and then thinking about the tolerances, which are going to be particular to whatever your business objective is. What is appropriate for each use case? So just taking this as an example, if you're trying to develop a quality standard for automated customer support, you've got a chatbot that you want to have be a support agent. There are going to be all kinds of risks for that, of course. One might be that the chatbot provides financial advice when it is not designed to do that. It's just designed to provide account support, for example. You're going to have several different test methodologies that you're going to use to evaluate different aspects of the system. You're going to have different metrics that you might use for each of those test methodologies. This is kind of the way that you're quantifying how well the system is performing. And then you're thinking about what kind of pass-fail tolerance you're going to accept. Obviously, for something like this, and the more sensitive the risk is, the tighter your pass-fail tolerance is going to have to be. And that will vary based on the type of use case. Another example is the chatbot isn't retrieving or citing the most relevant policy, or the most relevant document, essentially. There are test methodologies there is making sure that the retrieval is working correctly. Is it ranking the correct information appropriately? You can use metrics like MRR, mean reciprocal rank, set a pass-fail tolerance there, et cetera, and you keep going down. And the idea is you're building up this whole thing together is a quality standard, and you're building towards a gold quality standard so that the product that you're putting out there is hitting all of the criteria that it needs to hit, and you're systematically understanding how you've reached that and exactly what methodology your teams need to use in order to drive towards that result when you're comparing different models, different approaches, the techniques that Gordon showed, for example. And I just want to very quickly, compliance and regulatory considerations. Obviously, this is going to be a huge consideration for any financial application here. It's evolving very quickly. There's new regulation all the time. The EU AI Act, very recently, of course. There are huge consequences for non-compliance. I don't think I need to be going too deep into that. Beyond financial penalties, there's reputational damage. If you're going to deploy a generative AI product, there's a lot of risk with reputational damage. Even Google, who's at the forefront of this, got into a lot of trouble when they released their AI summaries a little prematurely, for example. But for non-compliance, it's starting to become like rule-based, where if you aren't following it, then there are some governmental or organizational consequences. And it goes beyond factual accuracy. It includes fairness, privacy, and transparency as kind of three big things I like to mention. So fairness is very important, ensuring that you're not discriminating or showing bias across your user base in particular, especially if you're serving end users. Privacy, you got to make sure that you're protecting sensitive financial information. You're not revealing any of that information inappropriately, or you're not utilizing something that shouldn't be utilized. And then transparency. This is particularly important for showing compliance. If you can explain your AI-driven decisions, if you can say, this is exactly why my chatbot generated this result, it was referring to this document, which came from this policy, which was issued by this organization, then you've got the full chain of transparency and accountability. Very, very useful. Key point here, it's really essential to define these gold standards, particularly in finance, because it's a very sensitive domain. It's going to help you ensure consistency across the way that you roll out your products. It's going to build trust, which is essential right now when trust is still a big issue for systems, for generative AI systems in particular. So if you want to take advantage of that, you have to make sure you're building trust. And again, facilitates regulatory compliance. Kolena, you got a little preview of it when we were looking there, but we're really helping organizations to adhere to these gold quality standards. We're bringing our knowledge in, but also we have a product which helps to drive towards that in a systematic and efficient manner. So Kolena helps you utilize benchmarks like the one we were looking at with FinanceBench, these advanced evaluation methods. And the whole goal is to make sure that these generative AI products are able to meet your own internal business standards. And just as a quick final illustration, it's really about, these gold standards are about focused evaluation on the system aspects that matter the most to you. So these are really the big categories for RAGs in general: correctness, behavior, and adversarial attacks. Correctness, pretty straightforward. Am I doing the correct thing? Am I retrieving the correct information? Behavior, am I acting appropriately? Am I not leaking personal identifying information, for example? Am I not hallucinating? Am I acting with the appropriate tone? Not giving financial advice? And then being able to deal with adversarial attacks. You don't want somebody coming in and jailbreaking, getting your generative AI system to do something that you didn't intend it to do. So you have to test against that, develop a gold standard for how your systems handle that situation. And again, not all of these will be relevant to every use case. And that's the idea of developing a gold standard that matters the most to you. So what I want to wrap up with here, and Gordon, I want to get your feedback on this, is just thinking about the future of RAG systems and generative AI in finance. RAG systems, even though they're drawing on this idea of information retrieval, which has been around for a long time, are themselves a new way of doing things, still very young and changing very rapidly, and going to continue to change this year and next year and the year after that. And foundational capabilities are changing a lot. The length of context windows continues to increase, which is going to make a big difference. So Gordon, I'm particularly curious, given your research in this area and your background, where you see things going from here and what implications that might have.
Yeah, I think there's really two factors in play here. One that we were just looking at is implementing a non-naive retrieval system is a lot of work. There's kind of an endless number of different components and optimizations that you will need to put in place to get desired retrieval behavior given a user's input query, and to keep that fast enough that you can actually use it as a part of your interactive application. So I think one of the big trends that we'll see is towards more pre-built RAG solutions. And often I think this will be coming from the model provider themselves. If having some sort of retrieval augmented generation is a key part of getting value out of Gen AI models, it's a clear value add for a company like OpenAI or Anthropic to add retrieval functionality to their own API. And indeed, we see this with current beta tool from OpenAI for file search. Retrieval augmented generation functionality is quite good, quite well implemented, quite performant. And you'll generally get better results if you use the thing that's coming from the model provider than if you try to build it in-house. I think the other reason why we want to probably rely on the model developers to provide these tools is the need for RAG is inversely proportional to the context length of a model and the cost per input token for a model. So the original kind of motivation behind setting up RAG as a technical system is when you have models that have, let's say, 4K token context windows, you need to be very careful to have the correct piece of information fed into context because you have a very limited number of tokens to use in your context window. It's common now for models with the Llama 3.1 family. We now have 128K context windows kind of as a minimum standard at this point. And with some of the Gemini models and others, you see you have 1 million or 2 million token long input context windows where you can fit many full-length novels. You don't need to be very picky about what you put into context. You can kind of shove anything in there. And indeed, with later models, you see this is very well highlighted in the latest Anthropic model card. You see with some of these later models that the previous shortcomings of using a huge long context where you have what you call the needle in a haystack problem, where you have a lot of stuff that's not what you want to look for. And the piece of information that you do want to look for is this tiny needle in this large haystack. You see that some of the latest frontier models have virtually perfect needle in a haystack performance. And so the real only downside that's left with not using huge contexts is the cost, which will continue to go down, I'm sure, and the lack of uniform support across all different models. So if you're going to use something like a 1+ million token context window, you're to some extent locked into a model like Gemini, where you have this extremely long context window. I expect these factors to change a lot in the next year, where worrying about input tokens is a lot less close to top of mind for people that are building Gen AI products.
Right. Yeah, exactly. That's my intuition as well. Yeah. Well, we're pretty much out of time. I apologize. We won't be able to get to these questions that you put in there, Christian. Those are good questions. But I did want to put up this further resources page. First thing I want to point out, questions, comments, something that we didn't get to, please reach out to me. I'd be happy to answer, happy to chat with you. Just skip@kolena.com. And here are some further resources. We've got a great ML metrics glossary. So if you're wondering what kind of metrics you might use to evaluate the systems, you're not sure where to start, we've got a great glossary that you can refer to here. We did a webinar just a couple of months ago on mastering RAG systems. So it goes a bit deeper into RAG optimization, more techniques that we didn't necessarily discuss here. It's not specific to the financial domain, but it is specific to RAGs. And we'll have a lot of great info for you. I realize this is kind of a cumbersome link. So if you just search for Kolena on YouTube, you should pop up. We've also got the AIQCon talks on YouTube. If you just search for AIQCON, AIQCon, a lot of good talks coming up, and a lot of those from partners like OpenAI, Anthropic. And then lastly, check out our blog. We've got a lot more best practices for ML, AI evaluation and testing in general. Gordon, thank you very much for joining. Thank you all in the audience for listening today, and we'll see you next time.
Thank you, everybody.